Hey everyone, welcome back to my channel again. This is a video I'm going to continue solving questions from Blind 75 Part 2, so stick around. Okay, so in the last video we solved the first two ones. Now we're just going to continue on and do contains duplicate over here. So this one is easy depending on how you look at it. So given an integer array nums, return true if any value appears at least twice in the array, and return false if every element is distinct. So essentially, over here 1 and 1 repeat, so this is true. Over here no numbers repeat, so this is false. And over here a bunch of numbers repeat, so this is true. But only on the first occurrence of the repetition do we want to return true, so we don't have to go through the entire array if we don't need to. So this one is, you can do a double for loop too, but in this case I'm gonna do another map set over here just to keep a track of all the numbers we've been through in the past. So I'm gonna say map of int, and it's just gonna be a simple int as the key and boolean as the value. So I'm gonna say if n range nums, and over here I'm gonna say if map set n exists. So if this returns true, then I just want to return over here true. Else, if that doesn't happen, then we want to store this as a number that exists. So we go n is equal to true. And if we go through the entire iteration, that means they're all unique, so we just return false at the end. So now let's run this over here. Yeah, this one's true. Let's submit this and see if it passes and how good do we do. Okay, so it's faster than 82% of online submissions, and then the memory usage is greater than 41%. So this one's pretty easy. You could do a double for loop too. It just would be more code and add more complexity, but really double for loops is where everyone starts off from. So if you say j is equal to I plus 1, and then j is less than the length of nums, and j plus plus. Okay, so we have that. I do need to make this iterable for I, and then essentially I'm saying if n is equal to nums at indices j, I want to return true. So this here should pass as well. So let me run this code. So map set declared but not used. Okay, that makes sense. That's one thing about Golang. Let's run this code again. So here we see we have so many nested blocks over here, and if we run this, it's definitely gonna run slower because it's a log. Sorry, no, it's of O and N squared time complexity. Over here, see, it's about 6. It's only faster than 6.77% of online submissions. But the other thing is that double for loops have a great space complexity. So over here we saved, I think, pretty sure we saved a little bit more space, because with the map we're sort of like storing old values and such. Okay, so this is done over here. Oh yeah, we went down by like 1 megabyte, almost 1. So product of array except self. So this one I read, I honestly did not understand this too much, but I'll try to read this. Given an integer array nums, so nums is what gets passed here, return an array answer such that answer at I is equal to the product of all elements of num except num equals I. Yeah, the product of any prefix or suffix of nums is guaranteed to fit in a 32-bit integer. You must write an algorithm that runs in O and N times square. I honestly didn't understand this too much, And even looking at the examples, I don't really completely understand what this says, but we're going to come back to this later as soon as I understand it. The next one is the maximum subarray. So this one here, given an integer array nums, find the contiguous subarray containing at least one number, which has the largest sum, and return its sum. Yeah, so this one, what you can do is start off with the double for loop again. So let's do that right now. So n is range nums, and then for j is equal to I plus 1, j is less than the length of nums, and then j plus plus plus. And I essentially just want to add them all and see what the max is. So I'll say var max int. Cool. So I want to store a temp over here. So temp is equal to 0. And I'm going to say temp, or sorry, temp is equal to n in this case. And then temp plus equals to the next following number, j. And essentially at the very end, I want to be like, if temp is greater than max, then I want to say max is equal to temp, and then I return max over here. So we run this code. This should pass something's, oh, nums. You have attempted to run code too soon. Let's run this. Output is 5, expecting 6. Let's see what we did wrong. At least one number. Oh, okay, so what I want to do is I want to put temp inside here. I don't want to get the absolute temp, which is what they give me over here at the very end. I want to see the temp at every position and store that in. So I want to toss that in here. Let me straighten this out so it's easy to read. Run this code and it passes here. Let's see if it passes all test cases. This is a double a for loop, so I'm expecting it to time out somewhere. This one, okay, so yeah, I didn't account for this because indice 1 is equal to that. So I guess I need to do this in two places, one here and one here. Or I can just say, actually, if len of nums is equal to 1, then I just return nums at that, and then I don't need to instantiate var over here. I can just do this. Cool. I think that would definitely work for that case at least. I'm not sure about the others because I'm expecting a timeout. This one is expected to wait, why is 1 expected here? Oh, because that. Oh, okay, so in that case I need to do this. So I need to move this also here. So in that case I need to do this. Expected -1. I guess we can also go to negative values, which is weird. Okay, then in that case, is this guaranteed to have a length of 1? Oh yeah, it is. So I can just say max is equal to nums at index array 0. Time limit exceeded. So there we go. So I hit a time limit execution error. So this is where we want to speed it up and not really use a double a for loop. So let me think about how we can do that here for a second. Okay, so I think we found another way here. So we gotta keep track of when it goes below 0. So we can say current sum is equal to 0 and our max sum is equal to the first indice, and then we just iterate over it. So n is equal to range nums over here, and then we do current sum is plus equals to, or we're just adding it, current sum plus current sum. Current sum is equal to current sum plus n, right? And then we need to see if current sum is greater than sum, and if so, then sum is equal to current sum. Otherwise, we also have to check current sum over here. If current sum is less than 0, we want to reset current sum over here. Because if current sum is less than 0, we don't want to keep adding because it could be more negative numbers, and it just could keep getting lower, whereas -1 is greater than like -4. So we just want to reset that to 0, and then at the outside we just return max sum over here. Let's run this code. Current sum is greater than sum. Oh, max sum. That's what I meant to say. Where else do we have sum? Oh, here. Okay. Let's run that. Okay, that passes over there. Let's submit. This was our time exceeded for the double for loop. And there we go. So we have this passing now. We are faster than 91% of online solutions, and our memory is 9.8. So essentially we walk through this right. So over here we pass in, it iterates first, gives it the first one. So this is -2 over here. And then it starts adding the current sum. So current sum now is -2. -2 is not greater than -2, so then it skips that. And -2 is less than 0, so then we just reset that to 0. So now it's like starting from over here. So now 1, current sum is equal to 1. 1 is greater than -2, so now this turns into 1, and we skip this. Then it goes to -3. So now it goes through this, it adds that to current sum, and now current sum is less than 0, so now we'll have to drop that to 0. Yeah, well, that's pretty much it for this solution over here. And that's it for this video, because we said we were going to do contains duplicate and maximum subarray over here. If you like this video, please show your support in the comment section, and the likes really goes a long way. And I will see you in the next video, where I tackle more of these array problems from the blind 75. Peace.